All right. In this lesson, we're going to talk about balancing chemical equations. When we balance a chemical reaction, you can add coefficients in front. This word in front means to the left. And I'll be adding coefficients in green here. So where it says in front, if your first language reads from right to left, you might think in front's to the right. But this is to the left of a compound. But you may not change the subscripts. For example, let's just have a balanced, we'll just put a chemical reaction on the bottom here. So our reactants here are going to be sodium, metal, reacting with chlorine gas. And then we produce sodium chloride. We want to balance this chemical reaction. We have two chlorine atoms here because every chlorine molecule has two chlorines in it. Again, chlorine is one of those molecules that ends up in this polyatomic elements box. So if you have chlorine by itself, it has to exist in a pair. Sodium chloride has one sodium and one chlorine. So this is not a balanced chemical equation. We cannot, this is not allowed, we cannot just put a little 2 subscript here. So we just put a little 2. Now all of a sudden we have one sodium, 2 chlorides. Looks like it's all balanced. This is not what sodium chloride looks like though. Sodium chloride is 1 sodium, 1 chloride in a 1-to-1 ratio in a crystal. It's not 1 sodium to 2 chlorides. So we can't put a 2 there. Instead, we can add a coefficient in front of the molecule or to the left, but we can't change the subscripts. Subscripts are the little number to the bottom right of the element symbol. I'm going to say to the bottom right. I know that doesn't fit in the blank, but it's specific of the element symbol. This is a subscript. This indicates that in a molecule of chlorine gas, we have 2 chlorine atoms. That's a subscript. Coefficients appear to the left. Of the chemical formula and indicate the number of moles of the substance in the equation. If I put a 2 here and a 2 here, this indicates that I have 2 sodium atoms reacting with 1 chlorine molecule to produce 2 sodium chlorides. I can add these subscripts because it doesn't change these coefficients, not a subscript. I can add these coefficients because it doesn't change my molecule. It just tells me I have more of this thing. So 2 parts sodium plus 1 part chlorine gives me 2 sodium chlorides. This word mole, which is right here, a mole is the chemical amount of a substance. It's a group of molecules, basically. It's also a specific number at the same time. If I say a pair of shoes, you know I'm talking about 2 shoes. If I say I'm talking about a dozen eggs, you know I'm talking about 12 eggs. Well, a mole is a very large number. A mole represents 6.02 times 10 to the 23 molecules or particles. A mole is the standard unit that measures the chemical amount of the substance. It is a convenient amount used by chemists. The unit symbol that we use to represent moles is MOL. So almost the word mole. We just cut off the E at the end. But that's the units. We measure it in moles. Molecules and particles and atoms are very, 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 very small. And so we need to have them in large groups in order to have any sort of measurable amount of them. Usually we measure them by mass. But the group of all of those molecules together is called a mole, and it actually means 6.02 times 10 to the 23, whatever you're talking about. It's a huge number. There is a scientist named Avogadro. He had other names. I don't remember them all. We call him Avogadro. Avogadro's number is based on his experiments. Now we say that it's based on the number of atoms in a 12-gram sample of carbon-12. He did experiments with gases, came up with this number as the number of particles that exist in one grouping that could be measured. The coefficients used to balance mass in a chemical equation represent the number of moles of each substance present in the equation. If you're on the InReach Google Classroom, there is some good videos, or if you just Google the TED Ed, how big is a mole, it will explain the number well. For Science 10, what you need to know is that it's a very large number. Because molecules are so small, we can only measure them noticeably without the use of incredible equipment by weighing them in these groups, these of massive amounts of molecules. This 3 here, this 3 coefficient is telling me that I have 3 moles of water molecules. Inside water, I have 2 hydrogens, but now I have 3 moles of water. So I can say that I have 6 moles of hydrogen total, because this subscript applies to the hydrogen. Inside a water molecule, there's no subscript for oxygen, so there's only 1 oxygen, but it also gets multiplied by the coefficient. The important takeaway here is that the coefficient multiplies both atoms, or if there's more than 2 atoms, it multiplies all the atoms inside of the formula. I'm just going to write a note here. The coefficient multiplies the entire formula. So it multiplies our 2 hydrogens inside the water molecule to give us 6 hydrogens. It also multiplies our 1 oxygen to give us 3 moles of oxygen. So in total, we have 9 moles of atoms. Over on the next side, we have 2 moles of sodium chloride formula units. Ionic compounds don't really form molecules, so that's why it says formula units instead of molecules. We have got 1 sodium in each sodium chloride, and we have 1 chloride in each sodium chloride. But we have this coefficient of 2, which will multiply both our chlorine and our sodium to give us 2 moles of sodium and 2 moles of chlorine. So in total, that's going to be 4 moles of atoms. We're going to use this skill to balance some chemical equations. Both sides of a chemical equation must have the same number of moles of each element. You cannot change the formula. You can only change the coefficients. You can only change the coefficients you add. That's why we wrote the unbalanced chemical equations in the last lesson, because those different compounds and elements that we wrote in the unbalanced equation can't change. The only thing that we can change is coefficients. First, we write the unbalanced chemical equation. Generally, leave elements that appear more than twice in the equations for last. More on that later. Balance the first element so that the number on the reactant side equals the number on the product side. Balance the second element in the same fashion. Balance hydrogens and oxygens last, if applicable. Well, the first reaction we have is only hydrogen and oxygen. Here's how I like to do it. I draw a line. right where my arrow is. Then I list out which types of atoms I have in my reactants and what types of atoms I have in my products. I have hydrogen and I have oxygen. I should have the same types of atoms in my products. I'll list them in the same order. Then I write how many of those atoms I have within the compounds, molecules, or elements that I start with. I start with 2 hydrogens on my reactant side because this hydrogen molecule has a subscript of 2. I also start with 2 oxygens for the same reason. On the product side, I have 2 hydrogens and I have 1 oxygen. Now I start to balance. I've got 2 hydrogens here and I've got 2 hydrogens here, so I'm happy. I don't need to change anything. If I go down, I've got 2 oxygens here. I only have 1 oxygen on the product side. Well, I'm going to have to multiply this oxygen by some number to get to 2. So I'm going to multiply my 1 oxygen by 2, and now I have 2 oxygen. However, I can't just put this number here and then act like I've done something. I need to put it as a coefficient. This 2 is my coefficient. That means I have 2 oxygens. That's where they came from. Notice, however, that this 2 doesn't just multiply the oxygen, it also multiplies the hydrogen. So if I put a coefficient in front of a molecule, I have to multiply all of the atoms in that molecule. So now I have 4 hydrogen. Now I have to revisit the hydrogen that I had on the reactant side. I started with 2, I need to get to 4. So I can multiply this by 2. That 2 that I multiply by has to become a coefficient. So 2 hydrogen, 2 moles of hydrogen react with 1 mole of oxygen to give me 2 moles of water. If there's no coefficient, there's an invisible 1 there. But on a numerical response on a quiz, sometimes you'll be asked to put the 1 there. But you don't need to when you're just writing out the chemical reaction. Let's take a look at this one. Calcium hydroxide plus hydrochloric acid forms calcium chloride and HOH, which is just water. I'm going to show you a trick here. When we're dealing with polyatomic ions, I'm going to treat them as one thing. I'm going to treat polyatomic ions as if they're one thing, unless they're breaking down. This hydroxide, we can treat as one thing because we have an OH over here. So I'm going to treat hydroxide as one thing. I'm going to list what I have on my reactant side. I have calcium. I have hydroxide. I'm going to list it as one thing. It's a polyatomic ion. I have hydrogen by itself. And I have chlorine. I guess the hydrogen's not by itself, but I have an H with an HCl. This H here is this H here. So I'm going to say what happened in this reaction is that the hydroxides and the chlorides switched, or you can think of it as the calciums and the hydrogens switched. So you end up with calcium paired with chlorine, and this hydrogen paired with this hydroxide. I'll list the things in the same way on this side of the reaction. So calcium first, hydroxide, hydrogen, chlorine. I like to list them in the same order. I know that chlorine appears next, but then I can just line them up across the board. I start with 1 calcium. I start with 2 hydroxides, 1 hydrogen, 1 chloride. On my product side, I have 1 calcium, 2 chlorines, 1 hydroxide, 1 hydrogen. I'm just going to start at the top of the list and then make my way down. I have 1 calcium on this side, 1 calcium on this side. Don't need to change anything yet. 2 hydroxides on my reactant side, only 1 on my product side. So I go to the thing that has hydroxide in it, which is this water. I need to multiply it by 2 so that I get to 2 hydroxides. I have 2 on this side, or I have 2 on this side. I need to get to 2 on this side. But if I add in this 2, it needs to go in as a coefficient. This 2 doesn't just multiply the hydroxide, it also multiplies the hydrogen. So now I have 2 hydroxide, 2 hydrogen. Well, now my hydrogens aren't balanced. I have 2 hydrogen on my product side. I need to get to 2 hydrogen on my reactant side. To get from 1 to 2, I should multiply by 2. If I'm multiplying this hydrogen by 2, then the molecule that the hydrogen is part of, the hydrochloric acid here, the HCl, needs to get this 2 put in front. That's how I can multiply it by 2. But this 2 doesn't just multiply the hydrogen, it also multiplies the chlorine. Which actually brings us to a balanced equation. Now I can run through and check everything. I've got 1 calcium on this side, 1 calcium on this side, 2 hydroxides within calcium hydroxide on this side, 2 hydroxides because I have 2 separate water molecules on this side, 2 hydrogens because I have 2 molecules of hydrogen chloride on this side, 2 hydrogens because I have 2 water molecules on this side, 2 chlorines because I have 2 of these molecules on this side, and 2 chlorines because there were already 2 within this molecule on this side, which means I've got a balanced chemical equation. This takes some practice. I'd invite you to try some of these. I'm going to do number 4 with you, but give it a shot first and then I'll work through it. So for number 4, we'll list off what we have. We have aluminum and we have sulfur. We only have 2 elements. The difficulty here is that the numbers get large. Aluminum and sulfur react to form aluminum sulfide, which is 2 aluminums and 3 sulfur in it. I start with 1 aluminum on my product side and 8 sulfurs. Sorry, on my reactant side. On my product side, I end up with 2 aluminums and 3 sulfurs. If I started with my aluminum, I'd be like, okay, well, I need to put a 2 here. So a trick that I like to do is I like to start with the number. If I've got mismatched numbers, I start with the largest number. I've got 8 sulfurs on this side. I need to get to 8 sulfurs on this side. There's no whole number that I can multiply 3 by to get to 8. So I need to find the lowest common multiple of 3 and 8. Sometimes the easiest way to find the lowest common multiple is by multiplying the 2 numbers together. If I multiply 8 by 3, I end up with 24, which is a lot of sulfurs. So you might think that you're doing something wrong, but you're actually not. That's just the lowest common multiple I can get to. So if I had 3 molecules of sulfur, which each have 8 sulfur in them, that means that I have 24 sulfurs, atoms of sulfur, on my reactant side. And if I multiply my 3 atoms of sulfur within my aluminum sulfide by 8, that's going to bring me to 24 atoms of sulfur on my product side. This 8 doesn't just multiply the sulfur though, because the sulfur and the aluminum are stuck together. So I must also multiply my 2 aluminums by 8 to bring me to 16 aluminums total. Now I can revisit my aluminums that are by themselves, and I will find that I need 16, a coefficient of 16, in order to reach a balanced amount of aluminum. These are large coefficients compared to what I did on the previous practice, where it was just 2 was the largest number. Sometimes it happens like that, especially in molecules that have a lot of a certain atom in them, like this sulfur molecule. Try the practice out, and in our next lesson, we'll talk through the 5 common types of chemical reactions and the 5 types that you will see in Science 10.